Welcome to the third episode of Einstein's Entanglement, a short video series based on the book Einstein's Entanglement, Bell Inequalities, Relativity, and the Qubit, published in 2024 by Oxford University Press. I'm your host and co-author of the book, Professor Stuckey. In this episode, I will introduce and resolve the paradox of link contraction, where according to Oxford Languages and Google, a paradox is a seemingly absurd or self-contradictory statement or proposition that when investigated or explained may prove to be well-founded or true. Here's the paradox of link contraction. Alice and Bob are moving relative to each other. Alice's measurements confirm that Bob's meter sticks are shorter than hers. Bob's measurements confirm that Alice's meter sticks are shorter than his. Special relativity says Alice and Bob are both right. This is seemingly self-contradictory, but I assure you it is true, and by the end of this video, this paradox will be resolved using Einstein's principal reconstruction of the Lorentz transformations. In episode 2, I used the Mermin device to explain the mystery of quantum entanglement for the general reader, and I introduced Mermin's challenge to the physicist reader to resolve that mystery for the general reader without spooky actions at a distance, or causes from the future, or superdeterministic control of experimental procedures, or infinitely many realities, etc. All of these solutions have existed for decades, yet none has garnered consensus support. Why? Because they all violate something deemed necessary for the constructive or causal explanation that they are attempting to follow. Indeed, it is provably impossible for a constructive account of quantum entanglement to do otherwise. So they're all self-refuting in a sense. That's why the prospects for a consensus constructive solution to the mystery of Einstein's entanglement are slim to none. Thus, we have the impasse in quantum foundations that has existed for decades. In this video, I will explain how Einstein responded to a similar situation in the late 1800s. In solving the greatest mystery of physics at that time, he gave up constructive efforts in despair and reconstructed the Lorentz transformations via the relativity principle and light postulate, yielding the fantastically successful principal theory of special relativity in 1905. Today, we still have no consensus constructive counterpart to special relativity, so this historical example might provide a clue as to how to solve the mystery of Einstein's entanglement in principal fashion today. The mystery physicists were dealing with in the late 1800s was the observer independence of the speed of light c. Maxwell's equations predicted the existence of electromagnetic waves moving with a speed of 300,000 kilometers per second, or c for short. Since waves are the oscillations of some medium, for example, ocean waves are undulating water and sound waves are vibrating air, clearly there must be some oscillating medium for the electromagnetic waves, which physicists called the luminiferous ether. In 1887, Albert Michelson and Edward Morley devised a very precise way to detect Earth's motion through the ether using a device called an interferometer. Here's a picture of theirs. As the interferometer is rotated relative to its direction of motion through the ether, the relative speed of the light waves in the two orthogonal paths containing mirrors 1 and 2 varies, and that changes the resulting interference pattern seen as fringes through the eyepiece. This device is able to detect very small changes in the speed of light as Earth orbits the Sun, so it should definitely be able to establish Earth's movement through the ether. But to their amazement, the interference fringes never changed, suggesting the Earth is not moving relative to the ether at all. Now, that's pretty hard to believe since their lab was rotating around Earth's axis, which is revolving around the Sun, which is revolving around the galactic center, which is moving through the cosmic microwave background. And yet, amazingly, their lab was at rest with respect to the ether. There had to be another answer, and there was, but it didn't turn out to be what physicists expected. Here's where physicists expected to find the answer. Oliver Heaviside showed that a charge's electric field would be distorted when the charge was moving in the ether. If the length of Michelson and Morley's interferometer shrank in just the right way along its motion in the ether, then Michelson and Morley would not detect changes in their measured value for the speed of light. So, physicists just needed to find the cause of this link contraction to explain the observer independence of c. And that would give you the Lorentz transformations explaining how Maxwell's equations were to be transformed from one inertial reference frame to another. Causal mechanism producing link contraction leading to the observer independence of c whence the Lorentz transformations. But, as with constructive attempts to explain quantum entanglement, no constructive attempt to explain length contraction was able to achieve consensus support, Einstein's included. So, as I explained in episode 1, Einstein gave up his constructive efforts in despair and turned to principal explanation. Again, he said the reason everyone keeps measuring the same value for the speed of light c, regardless of how they move relative to the source, is because of the relativity principle. That is, the relativity principle says all the laws of physics are the same in all inertial reference frames. And since c is a constant of nature according to Maxwell's equations of electromagnetism, everyone has to measure the same value for c, even if their perspectives on reality, their inertial reference frames, are moving relative to each other. Thus, his fabulously successful theory of special relativity was born in 1905. So, we have Einstein's principal solution to the mystery of length contraction as follows. The relativity principle and Maxwell's equations demand the observer independence of c, whence the Lorentz transformations containing length contraction. Notice that in this view, length contraction is not a dynamical effect resulting from some causal mechanism like the luminiferous ether. Length contraction is a kinematic fact that follows from the observer independence of c that follows from the relativity principle and Maxwell's equations. Now let me show you how the paradox of length contraction is resolved. The Lorentz transformations simply convert the space and time coordinates uppercase x and t of an event in one reference frame to space and time coordinates lowercase x and t for that same event in another reference frame. Accordingly, consider the following three events labeled with the x and t space and time coordinates of two different reference frames in motion relative to each other. The times here are exaggerated for effect. In one reference frame, uppercase x and t, you have three sisters all the same age. Alice is one of them. In the other reference frame, lowercase x and t, you have two brothers both the same age. Bob is one of them. The sisters and the brothers agree on the space and time data labeling these three events, as related by the Lorentz transformations, with the exaggerated time differences. Since the brothers are the same age, events 1 and 2 are simultaneous for them, and it's obvious from their organization of the events that the sisters' meter sticks are short, since the sisters measure the distance between the brothers to be 1,250 kilometers, while the brothers measure it to be just 1,000 kilometers. But the sisters are the same age, so they say event 2 happened 2.5 years before event 1. The event that happened at the same time as event 1 is event 3. So from their perspective, it's the brothers' meter sticks that are short, since the brothers measure the distance between Sarah and Kim to be 1,000 kilometers, while the sisters measure it to be just 800 kilometers. This is called the relativity of simultaneity. That is, which events happen at the same time depends on your perspective. It's very counterintuitive, because it means that whether or not the brothers are the same age and whether or not the sisters are the same age depends on your perspective. We'll see something equally counterintuitive called average-only conservation regarding quantum entanglement in the next episode. In that next episode, I'll explain how quantum information theorists reconstructed the Hilbert space formalism of quantum mechanics, so that it follows from an experimentally motivated postulate called information invariance and continuity, which is equivalent to the observer independence of Planck's constant h. This is in total analogy to Einstein's reconstruction of the Lorentz transformations, such that they follow from the experimentally motivated light postulate, i.e. the observer independence of the speed of light c. These experimentally motivated postulates must be true if the relativity principle with Maxwell's equations for c and Planck's radiation law for h are all true. Thus, quantum information theorists have answered Ravelli's challenge and rendered quantum mechanics a principal theory exactly like Einstein's principal theory of special relativity. Accordingly, it will be obvious how they solved the mystery of Einstein's entanglement.